Hi everyone, welcome back to JDCodebase. In this video, we are going to learn how to implement a stack using a linked list in JavaScript. We already seen how a stack works and also implement it using an array. Now let's understand the linked list version. Also see how it is a bit more flexible than array based one. So in this video, we will implement stack using the linked list in JavaScript, understand the main operation push, pop, peek, and isEmpty, and finally compare it with the array based stack we made earlier. So let's start step by step. So now you might be thinking we already made a stack using array, so why use a linked list now? Well, there are a few good reasons. A linked list stack is a dynamic, it does not have a fixed size, and it uses memory efficiently, no empty spaces like in array, and we do not have to worry about presizing or capacity. So it is perfect when we do not know how many elements will be added. Simple, right? So let's move on and see how it actually works. So the basic idea is this: we will treat the linked list like a stack, and both insertion and deletion will happen only at one end, the head, which we will call the top. Like if you so each node will have data and the next data to store the value and next to point to next node, and our top pointer will always point to the head node, the top of the stack. So let's move to the VS Code and write the node structure for this. So class node constructor, and it takes value data, and now this dot data is equal to data, and this dot next is equal to null. So this class will help us create nodes. Each node stores data and a link to the next node. That is nice and simple. So now we will create our stack class. Class stack and constructor. Now this dot top is equal to null, and it is initially empty. So here this top will always point to the top of the stack. At the beginning it is the null because the stack is empty. Now our base setup is done. Let's move to operation. So add our push method to insert elements. Push data, it takes data value, and make a const new node is equal to new node data. New node dot next is equal to this dot top, and this dot top is equal to new node, and write console.log top data push to the stack. So here what happening is when we push a new element, we create a new node by const new node is equal to new node data. Then we connect it to the previous top and update the pointer to the new node, and that is the element added to the at the top, and this work in the big of one time constant time. So now let's handle pop operation, which removes the top element. So pop, and check well if this dot top is equal to null. Then console.log stack underflow, it's underflow situation, and return this. After that write console.log this dot top dot, oh I forgot to curly braces, this dot top dot data pop from stack, and return, oh sorry I have to, this dot top is equal to this dot top dot next. So here we first check if the stack is empty or not. If yes, we just print stack underflow, and if otherwise we print the top element being removed and move the top pointer to the next node, means this dot top is equal to this dot top dot next. So this also works in big of one time. Now two small but useful function peek and isEmpty. So peek is the if this dot top is equal to null, same as the pop operation. Write console.log stack is empty and return this. Else write console.log top element is this dot top dot data. And next one is the isEmpty, and in this just write return this dot top is equal to null, a simple one-liner solution. So here peek just show the top element without removing any element, and isEmpty returns true or false based on whether the stack is empty or not. So now let's check whether how this works. So const stack is equal to new stack and stack dot push 10 stack dot push 20 and stack dot push 30. And if I console.log stack not 27, I get 10 push to stack, 20 push to stack, and 30 push to stack, and I get this stack is top net 20, 30, 20, and 10. And if I want to remove stack dot pop, I get now 30 is pop from the stack. And to confirm this, just write this. See, now the data is 20, it removes the 30 from this. And whether the stack is empty and stack dot peek, so I get the stack is empty here at this time, I think. Yeah, so let's move to the we already see the push, pop, peek, and isEmpty. Now let's quickly compare array based versus linked list based stack. So both works fine. In the size is in array base is fixed, and resizing means in linked list it is a dynamic. Memory usage may waste space, and it is actioned. Implementation speed is simpler, but it is slightly complex, and speed of push and pop is both of the big of one, and overflow chance is possible in the array, but there is no overflow chance in the linked list. But linked list gives us the flexibility when the size is not fixed. So linked list is winner here. So let's quickly summarize what we learned today. Stack can be implemented using array or linked list both, and linked list based stack is more dynamic and flexible, and operation push, pop, peek, and isEmpty all in the big of one time, and it is great when you do not know how many elements you will store. So in the next video we will see some real life application of stack like function calls, browser history, undo, redo, and more. So stay tuned for that. If you find this video helpful, don't forget to like, share, and subscribe to JDCodebase for more short and practical DSA tutorial in JavaScript. See you in the next one.